Welcome everyone. In this video, let us simplify this question. Here we have 5x is equal to 160x raised to power minus 2 over 3. Okay, now let us solve this question right here. We have 5x is equal to 160x raised to power minus 2 over 3. Okay, first, we are going to divide the both sides of the equation with the coefficient of x, which in this case it is 5 over 5 over 5. 5 cancels out 5. You are left with x is equal to 5. We divide 160. You are left with 32. So that will be 32 times x raised to power minus 2 over 3. Okay, now at this junction, we are going to apply one of the principles of indices, which if you have an unknown number which has a negative power minus a, then the minus simply represents 1 over. So your minus represents 1 over x, the unknown number, power of a. Okay, now applying this rule over here, you have x is equal to 32 times power minus represents 1 over, then you have x raised to power 2 over 3, raised to power 2 over 3, okay, over 1, right? Now, at this junction, you're having x is equal to 32 times 1 is 32 over 1 times x raised to power 2 over 3 is equal to x raised to power 2 over 3. Now, we are going to cross multiply. Is x over 1. We are going to cross multiply. Okay? Now, once you cross multiply, x will multiply x raised to power 2 over 3. So that will be x times x raised to power 2 over 3 is equal to 1. We multiply 32. 1 times 32. Okay? Now, the power of x right here is 1, right? Good. Now, at this junction, we are also going to apply one of the principles of indices, which if you have an unknown number, right, y raised to power a times y raised to power b, right, this is equal to y raised to power a plus b. In this case, you are going to choose one of the similar number, y, and then since they are joined by times, you are going to add the power. You're going to sum up the power, that will be a plus b. Okay? Now in this case, x times x, we're going to choose one x, right? And since they are joined by times, we are going to add the power. That will be 1 plus 2 over 3. 1 plus 2 over 3 is equal to 32. Now, you are having x. The LCM of 1 and 3 is 3. How many times can 1 go in? 3. 3 times, right? 3 times 1, 3. Right? Good. How many times can 3 go in? 3. 1 times. 1 times 2 is 2. Plus 2 is equal to 32. X, 3 plus 2, 5 over 3 is equal to 32. Okay? Now, at this junction, we are having a fractional power, 5 over 3. Right? Now, we are also going to apply one of the principles of indices, which in this case, you have x raised to power a over b, right? This is equal to, in brackets, b root x all raised to power a. In other words, the denominator will eventually become the root sign, while the numerator will be the power of the expression. Okay? Now, applying this principle to this question, we're having 5 over 3. 3 right here, which is our denominator, will be the roots, cube roots, right? X all raised to power 5, right, is equal to 32, right? Now, you're having cube root x raised to power 5 is equal to 32, okay? Now, let me clean up this. Let me clean up so we can have space to solve. Now, 32 can be expressed as 2 times 2 times 2 times 2 times 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 16 times 2 will give us 32. Okay? In other words, 2 raised to power 5 will give us 32. Right? Okay? Now, in place of 32, we are going to write down 2 raised to power 5. So that will be into bracket cube root x all raised to power 5 is equal to 2 raised to power 5. Now, 5 here, power 5 here, power 5 here are in both sides of the equation. So, they are going to cancel out. You'll be left with cube root x is equal to 2. Cube root x is equal to 2. Now, at this junction, we are going to cube both sides of the equation. So, all cube, all cube. We are going to cube both sides of the equation. Cube, we cancel out cube root. You are left with x is equal to 2 raised to the power 3 is 2 times 2 times 2. 2 in 3 places. Okay, x is equal to 2 times 2, 4. 4 times 2 will give us 8. So therefore, x is equal to 8. Okay, good. This is the final answer to this question.